Hey guys, how are you doing? So this is another question of the playlist, probability playlist, right? So basically, this question is a classic question of uh, finding the number of finding the expected value using indicator random variable. So I hope you have you know what is indicator random variable, indicator RV. If you don't, I'll suggest you to watch that 110 course, 110 I guess, that 110 probability course. It's a very good course for probabilities and for the probability in quantitative research roles. So I'll suggest that you watch that video. It's a very good course. The professor of that, it's not Stanford, I don't know, it's Harvard, Stanford, I don't exactly remember, but it's pretty nice. The video, the professor is, I like the professor, the professor as a professor is very good, like his way of teaching. Anyways, let's move on to this question. I'm hoping you know what indicator random variable is. If not, then you can watch this video to get a brief idea. So what is the expected number of fixed position? Okay, we have to, and fixed position is when pk equal to k for basically we have this number from 1 to n, we have a sequence from 1 to n, and we can permute it anyhow. And if at index k the value is k, it means that the k is a fixed point. So we have to find out the number of the expected number of fixed points and over all the arrangements. Okay, so how does indicator random variable help? So we will denote the indicator random variable I as 1 and 0. Indicator random variables are only values either 1 or 0. 1 if ith index is fixed. If ith index is fixed, if ith index is not fixed, if ith index is fixed or ith index is not fixed. Okay, this is it. So basically our number of the number of fixed points will be how much? Summation of, like there is a fixed point at 1, if there is a fixed point at 1, if there is a fixed point at 2, and all up till n, right? This will be the sum. If it will be 1 if the ith index is fixed. This means that the total number of fixed points will be given by this. We can write expected value of n to be expected value of I1 plus I2 plus dot 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 in, right? Now there is this excellent result of expected values which says, I am discussing the result over here. The result says expected value of x plus y is equal to expected value of x plus expected value of y. This is pretty normal. If x and y are independent, then it's okay, you can understand that, yeah, this is obvious. But if x and y are not independent, still this holds. Y are not independent, still this holds. And that is what makes this result a very interesting result and helps us solve this. Okay, so let's get back to the question. So we can basically, what I meant was, we can break each of these into E of I1 plus E of I2 plus E of I3 plus dot 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 E of In, right? We can do this. Now we know that expected value of I1 will be 1 into probability that I1, like 1 is fixed, index 1 is fixed, index 1 is fixed plus 0 into probability of index 1 not being fixed. Let's generalize it for an I. Okay, index I is not fixed, index I is fixed. So this part is anyway 0 because we are multiplying it with a 0, and 1 will be 1 into this probability that index I is fixed. Probability index I is fixed. So that is what we need to find out. How exactly can we find that out? Let's say index I is fixed means I is here at I, right? At ith index I is there. So we can arrange the rest of all of them with a in n minus 1 factorial ways, and the total number of arrangements is n factorial. So basically we get 1 by n as the probability index I being fixed, isn't it? So if that is the case, then we then it's independent of I. So basically E of n will be n into, as all of these are 1 by n, so 1 by n times n will be 1. So the expected number of fixed points over all permutations will be equal to 1. So this is how we solve this question using the indicator random variables. Like, this creates a very easy method for us to solve. If you have thought of solving it using I into qi, where qi is the probability that there are I number of fixed points in that in some permutations, then the question would have been a lot tougher to find out this qi value and then finding out the summation, and you will find out, and you can try it out using this method, and you will get it, it is getting pretty tough. The summation is getting pretty tough, and at times there will be summations which will be obviously solvable somehow, but it will be pretty tough for you to solve at, let's say, at some exam or if you are attempting it somewhere. You will it will be pretty difficult to get to a value, something like this. So at times qi finding out is itself difficult. The number of the probability in which there are I pupils or I indexes are fixed or something like that. You're getting my point. So that's why we use indicator random variable, and this works as a magic. This works as a magic to solve a lot of questions. So I hope this video helps. So please keep watching. Okay then, bye.